大家好。那么下一场的话就是我们关于这个 Vtune 和这个以及其他一些英特尔的关于性能分析优化的一些这个工具的一些介绍。那么11的话是我们英特尔这边 Vtune 的产品开发总监所以他会给我们介绍一下英特尔对于在这个英特尔平台上面去做性能分析和优化的一些工具的一些介绍。那么在他讲的过程当中的话，如果有任何的问题，我们欢迎大家能够举手，然后我们能够及时的去做一些交流，好吧？下面我们就欢迎 Sri，so welcome Sri。
Good morning. Can you hear me all right in the back?
Yeah.
Yeah. Good. Okay. So what I'm going to cover today is give you a overview of the Intel's analysis tool, but also kind of put it in perspective. We have a lot of tools that can be used. So I just wanted to say a few words in the beginning to just understanding the kind of analysis tools we have and making sense of them, right? So you have in the design category, so maybe if you were in the keynote, then you also heard about if you wanted to add threading into your code or vectorization or other kinds of things in the future like offload and SQL offload. You would be using a tool, analysis tool that analyzes your code and then gives you some options. It's really an assistant, right? So it helps you, it aids you in trying to redesign your code, right? Refactor your code to be more vector, more parallel, more threaded, and things like that. That's what the advisor is. And then the correctness is, so even though it does some performance modeling and other things, not to be confused that it is a replacement for you. It's meant to be playing a role early in the story when you are really doing a big code changes, global code changes, where if you change your data structure, you will have to make changes in many places in your code, right? Those kind of things are not a typical optimization things. They are more like code refactoring operation, advisory testing, or that kind of things. When you're especially looking at threading or vectorization.
Sri, could you be louder? It's kind of trailing
Okay,
off.
then maybe I should. Yeah.
So that is the design or design part of it is advisor. So that's the tool you would use. And for correctness, so once you have added threading or vectorization, you may have introduced errors in your program, right? Or they may be there. And sometimes it's not even your code, and you are refactoring the code to improve somebody else's code. Because in the real world, you don't write all the code you're working on. You're working on code that many people have shaped it over the lifetime. And so in that case, then if there are any kind of data races or you're allocating memory and not freeing it, and as a result, essentially your application is going to use up all of the virtual memory, and at some point it's going to not function anymore, right? So that's the typical memory leaks. And then you have, when you add threading, you may introduce new kind of errors which are even harder to debug than even memory errors. Memory errors themselves are harder to debug, and you would have it even in the single-threaded program. But with a multi-threaded program, you may introduce data races, or you may introduce deadlocks and things like that. And so you want an analysis tool that can actually find those errors, whether they occur or not, right? So the inspector is a tool that actually, the error doesn't have to actually cause any bad things during the run that we profile. We can still detect those issues and problems and tell you, hey, you have a memory leak or you have a data race, and that this maybe didn't cause any bad behavior in this particular run, but it can in the future run, right? So those kind of things we can predict. And then the performance area. So after you have gotten your program functional and you coded everything you needed to code and you have implemented all the features, then you're getting into the stage, is it really ready to release? I mean, does it perform reasonably well? And for some codes, it may be more important than other codes, right, for some applications, because especially if you're in HPC or you're doing any kind of big enterprise servers, then the throughput is one measure of how good a code that you have built. And so then you need to tune, you need to characterize, you need to figure out where the bottlenecks are. And there, I wanted to just show you that Vtune is the tool that you would use. So basically we have three tools. So advisor, but during the design stage when you're doing various kind of adding new design elements to an existing code base, right? Or you're trying to get it to function correctly, so you use inspector at that stage. And then you, during the next stage, when you're ready to optimize and before releasing it, then that's when you use Vtune. So the Vtune, so then Vtune has a rich set of features, as I talked about in the keynote. So you start with snapshots. These are new things. Sorry, the background color is not coming out so well, but what you see here is under the wide angle lens, you see the snapshots. So that would be the very, like if you're looking from aeroplane and looking at a city, you see a lot of details, but not as many details, right? So it's the widest angle lens, or it's what you can say something like a 30,000 foot view of what's happening. And then you have something as you come down and then the aeroplane is landing, and then you can see a lot more detail, but still not as much as when you actually land and look at the details. So as you go into the right-hand side, in this extreme, you're going to see the more classical Vtune features, if you're familiar with it, like the hotspot analysis or microarchitecture analysis. So these are all relevant, but the way you would do that is you would use the snapshots to get a quick readout of which type of analysis I need to do, and if your application is probably too big, maybe use Platform Profiler to narrow the scope for which you're going to do the deep analysis, right? So if you have especially a workload that may be running for many hours or even days, you may not want to do that kind of a deep analysis on that because it will take a lot of time to compute the profile. And in fact, Vtune might not be able to compute it at some point. We're going to hit the limit in terms of how much data it collects. Because pretty soon you'll collect tens of gigabytes of detailed profile data, and that's too much to handle. So that means you need different ways of conquering this problem, right? You start with figuring out what type of an analysis to do, then you figure out where to focus in terms of if it is a long life duration, or if it is you want to know in what phases what kind of a hardware bottlenecks are occurring. You can use Platform Profiler, and then you go into the code. So I spent a little bit more time on this one, but I thought it is important, so I just wanted to level set on that. So next set of foils are going to be more talking about each of them in a little bit of depth, not too much depth, because there are other people who will come right after me. Ang is going to come, and he's actually going to talk to you in a case study-driven way, how you use these analysis types to solve the problems, performance problems. So that will be a lot more detail. And then we have more detailed talks later on in the track. They come from different aspects, like from a persistent memory domain perspective. Jackson is going to talk about how you use Vtune and other analysis tools to optimize your persistent memory applications, or even applications that use often persistent memory modules, but really they are volatile mode, right? So what we call the memory model. So he'll talk more about that. And then we have Sudha going to talk about, if you're really interested in opt-in DC persistent memory, in terms of really knowing about the architecture and what the performance implications, right? So if you're a software person and you want to comprehend how does is the reads and writes symmetrical or not symmetrical, or is and also at what granularity are the reads and writes happening to this particular memory DIMMs. So these are the kind of things she'll talk in more depth about, giving you some insight into how to understand the technology itself, so then you can start to have some intuition about, as you're building applications, what kind of performance issues you might get into, or how to optimally use it. And then we have also Roman and Sergey going to talk about how to build persistent memory applications. Then, and also how to tune your storage applications using SPDK, or whether you're using SPDK or not, you can still use Vtune if you have any kind of storage intensive application. But you can also use it on SPDK, because we do have awareness of SPDK and the user mod scheduling and polling that happens, so you get an accurate picture of it. Okay. So that is a good overview of the next day and a half or so. And then, so what I'm going to go now is really starting with the performance first. So I'm going to go through the snapshots to essentially show you a little bit more about what you can get from a snapshot in terms of the performance summary. So basically, application performance snapshot. So there are a few varieties depending on whether if you have a traditional server application, then you use application performance snapshot that runs on a single node, and then collecting essentially giving you something like this. And again, they don't come out very well. I don't know the next one. Let me just see if the next one is any better. Yeah, this is probably a little better. So what you see here is really the report that you get when you run on an application. So when you run your application, you can start the snapshot pretty easy. A simple command says, okay, start the snapshot, and then when you run with your application, you end the snapshot tool, and then it just generates you an HTML report that you can just open up in your favorite browser, and then what you're seeing here is a summary, is giving you a very condensed version of saying a CPU utilization is 41.5%, and then there's a text that kind of tells you how to interpret that, and again it is telling you that memory is 59%. That's probably not good, because and then it's going to tell you what you can do to tune for the memory to reduce the amount of the memory boundness you have in your application. Then similarly, for if you have a very compute intense thing, then you also get the FP, the floating point unit utilization rates and things like that. So basically, at this point, then it also tells you learn more, and then it tells you what you can do. So if you click on that, it'll pop up some more advice, tells you go maybe do this type of analysis in Vtune. So for example, memory boundness, it might tell you to go do memory access analysis in Vtune. And that actually tells you which parts of your data, the large objects you have in your application, are the ones that are putting the pressure on the memory. And basically, when you're memory bound, you're stalling, right? The CPU is stalling for the data to come from the memory. That's how we determine it's memory bound, because we look at a lot of very detailed performance metrics that are coming from the hardware to know that this particular CPU stalls are correlated to some pending reads or writes. That's how we know it's memory bound.
Sorry, question.
Yeah.
So for the snapshot, how long do you have to run as minimum to get a snapshot?
No, you can, as long as your application runs. They're very easy to scale to whatever. If you have an application that works for a long period of time, you can run for a long period of time. So basically, the way you have to decide is what is the representative workload that you have, and then you just that way what you're getting is meaningful. So the same thing with any profiling thing is, if you have a representative workload, and then so if you have your application and you have a particular input that drives that application, and that's a representative application, then you run the snapshot, you get a good readout of what the bottlenecks are, right, at the high level. So it could be run for a long period of time. If that particular representative workload takes a long time, that's okay. And if you have a smaller workload, that some input that still gives you a representative thing, then maybe that's preferred, right? So that way you don't spend a lot of time just profiling.
So I started.
And then do nothing, and then when the application ends, the report pops up. Yeah.
Got it.
Yeah, it's very simple. And then we have a few varieties. Basically, if you really have a very storage intensive, like we also have another variety of snapshot called storage snapshot, and that actually focuses a little bit more on really your block I/O and file I/O operations in your application, and also the actual hardware, the metrics that come from the hard drives or SSDs. So you get a similar kind of notion again. It tells you, essentially it tells you what percentage of the CPU time you're waiting on I/O. That's a little bit harder than you think, because there is no good way to measure that, because many times you may be, you cannot attribute an I/O. Basically, some kind of a idle time in the CPU is not always attributed to the thing. So you have to do a little bit more to figure out how that is, but I think we have a reasonable statement that gives you. So that's one good way to know, essentially, if you have, so even if you have a lot of file I/O or any kind of block I/O, but you are not really wasting any CPU cycles, maybe you have a reasonably good implementation of that. But on the other hand, if your CPU is waiting a lot of time on I/O, that's how you know that it's something you need to solve. But also it tells you if you needed a higher device or a higher performance device, because sometimes easiest thing is you're running on a very low performance drive, and all you needed to do is swap it with a high performance drive, and then you. Right.
Sorry, question again. So on the CPU idling, in the Linux kernel there's a I/O wait.
Mm-hmm.
Is this basically the visualization of the I/O wait?
I think what we found is the I/O, it doesn't always work. So I don't know what heuristic our guys use, but there was a little bit more involved than I/O 8.
So it's more accurate than I/O wait.
We think.
Okay.
You guys can tell us.
Yeah, I/O wait is kind of arguable.
Yeah, I think, I don't remember on top of my mind, I'm not the expert on this one, right? So there are, I think, who here, I think maybe nobody in this room, either maybe Roman or somebody might know. Is he here? No. Okay. So we can find that out, but let me get back to you on that.
Yeah, I will follow up with you.
So the next one is we're moving in that continuum, right? So from the snapshots to now platform profiler, which is somewhere in the middle. And what does that do? So basically that essentially does, again, it's pretty easy to use, but it is a little bit more involved in terms of how much profile, it can generate a rich profile, yet it is not very code-centric profile. It's really about your metrics over time for different topologies. So you start with something like a system topology. So I don't think you guys are seeing it very well because this screen seems very grainy. But you see a server topology, and then you from there, and at the same time you see that topology, you also see at the server level lots of different metrics, like a CP, aggregate CPI for the server, aggregate amount of the disk I/O, bandwidth, read bandwidth, write bandwidth over time, number of IOPS per time, things like that. And then if you're looking into the memory side, you're getting again per channel, you're breaking out the read bandwidth, write bandwidth over time. And then you also get other kind of metrics, like if it is an I/O thing, you also get the queue depth visualization. So with this one, you can, again, the usage model is pretty simple. You run your workload. Before you run your workload, you start the collection. Some of you are familiar with EMON, essentially EMON is how we collect a lot of the performance data from the hardware for this one. But we also use few other collectors to get the block trace and other things. And also we get some topology information. We extended EMON to get topology information because we found LS topo is not always accurate. And we may contribute some of that back, but essentially this is still something we only introduced as a preview last year, and it's getting significant interest from various cloud customers and people that really care about platform performance. This is the tool of choice now. And so this may or may not be attractive to, may be relevant for software only people, but if you are a much more complex workload and you can handle it using the deep analysis, my recommendation would be take a look at it and then figure out how to gain some insights and what parts to focus on it, and then go transition into the deeper analysis. And the reason we also built this one is traditionally Vtune did not have I/O or memory profiling, and that always was a highly demanded feature request. But we never, 5 years ago, 4 years ago, we didn't have any support for it. So mostly we would say look at CPU mostly to indirectly figure out if you have some out of go to use other tools. What we found out that the PCI complex is getting very, very complicated, as well as with the multi-socketed systems, it's getting very complicated on the memory side as well. So you really needed to, most of the time, you couldn't really figure out the performance issues by purely looking from it, profiling the CPU side of it. So we needed to really do the entire platform. And so we started to work on them, and now this similar kind of data collection is also you see in the deep analysis. So it's just that what you see, some of the metrics you see in platform analysis is also available in the other ones, but they would be correlated with the software context. That's the only difference. Right? The main difference is here you don't have any kind of software context. What you're seeing is for the entire duration, you can zoom in and zoom out into this timeline, and it's giving you various metrics. And some metrics may be coming from the software tracing, and others are coming from the hardware. Then going into the deeper analysis. So for the deeper analysis, I'm just going to first introduce quickly. Didn't talk too much about it. I think you're going to cover the how the Vtune GUI looks and what are some of the secrets or tricks in terms of actually making an effective use of the GUI. But quickly let me say a few things. You see a lot of, this is one view within the Vtune where you're seeing basically all the functions. Basically, we look at all the functions in your code, and then giving you various kind of metrics and indicators, color coded, and then but also we give you the timeline view, so you can actually go and then for any given context, like if you selected a particular thread, like if it was a thread view, so you can actually pick instead of function list, you can say all the threads in the program, and then you can go back and then drill down into how that particular thread metrics look over time. But also, if you double click on any of the functions there, then it'll give you also the entire the call stack information, right? The context information. So that's the power of it. But so that means you can take the same profile data, you collect the profile data once, and then you can visualize it in many different ways. That's the power. Basically, at some point, it looks like everybody gets the same data, but really, what view can give you the insights, right? So if you have a particular problem, then you say, okay, I want to organize this data along this particular hierarchy, and I want to view it. And that's basically the real power. Any power user of Vtune, they know how to basically pick from the drop down and different ways of organizing these profiles, either function-oriented view, thread-oriented view, or and then there is a hierarchy. You start with a process thread and then function within it. And then there's some improvements we did recently was really to make it a little bit easy, because in the past we had a flat organization of all the different analysis types, and the names were also not very intuitive. So we felt we needed to really organize it a little better for you. So if you are getting started, then you actually have some way of conceptualizing, okay, what should I do first? If you've never done Vtune, what is the right thing to do? And then you can still get started, and it'll tell you. In the past, we used to say always go to the hotspots, because that's the easiest one to do, because it'll give you your top, say, 10 functions or 10 modules, depending on what you're looking at, what is the organization, at the top 10 lines of code that are the most expensive, right? That take the most time, or that take the most number of cycles, or that whatever event you're counting in terms of what your cost is. So, but these days you can also look at it and say, I'm not really interested in that, but I'm actually interested in, I have a multi-threaded application and I'm not getting good performance. Maybe I have a parallel imbalance in my parallelism, right? So the way the parallelism works is basically if you use any kind of classical OpenMP region or any other spawn a parallel region and then wait for every thread to finish their work, and then you have to synchronize using a barrier, then your slowest thread is going to be the one, and everybody else is waiting until the slowest thread is completing the work, right? So that means you're losing a lot of the CPU capacity, right? The potential compute that you have in the processor is wasted because you have basically, for whatever reason, one thread is going to, or few threads will take a longer time, and everybody else is just waiting, doing nothing. And so that kind of an analysis we can easily do using threading analysis, and we can concurrency or locks and waits, or sometimes you're spending too much time in your synchronization code, because just trying to acquire locks, release locks, and those things sometimes can be just too expensive because too many people are contending on that. So if you have contention on that, it will tell you how much time is wasted trying to acquire those locks. So those kind of analysis. And then you have more of the platform profiler I talked about. So these are more advanced analysis at the bottom. If you're really familiar with some of the platform or hardware server architectures, and you're an expert at how to know a lot about server architectures, you may go to platform profiler. And also if you are dabbling with how to offload your code into a GPU for acceleration, then we also have support for OpenCL. We can also show you in terms of the concurrency between when you're actually offloading it, how does it look? So we can actually show you in the same timeline, but also we can show you the number of parallelism in the GPU cores, right, the execution units with the GPU. And then it's easier to set up. So mostly you have a very an installer that comes that it's easy to install, quickly get started. We have a lot of cookbooks that tells you based on the type of problem domain you are on, our application domain, how do I do this particular thing I'm developing SPDK based application and I need to profile using Vtune. They have a cookbook. It's like a 2 or 3 page thing that tells you these are the steps you need to go through to use Vtune to profile and optimize your. And then let me just skip this part. Yes. This is the one I didn't talk about before, so I'm going to spend a little bit of time. So earlier I talked about thread affinity, right? So if you're doing any kind of TBB or OpenMP based parallelism or even P-threads, oftentimes one of the challenging problems in parallel programming is where is my data and where is my thread that's accessing the data, right? If the thread is scheduled on a different core than where the data is near to, right? So then essentially you have to migrate the data. And so the thread affinity based analysis we can do and tell you that. And also we start to do more advanced things, like if you're an HPC guy, often you will be doing what? You have some kind of a communication fabric on which the MPI communication sits. And so we actually have performance metrics that show you how your communication on the fabric, the host side interface is going to look like. And then tuning for SPDK, DPDK, there is actually a talk, I think it's tomorrow. So you can learn more about it, but this is very new features. I'm familiar with it already. That's because it's probably only a few months old in terms of the SPDK or DPDK awareness. SPDK has been there for a little while, but we also now extended it to DPDK. So basically, maybe the key point on this one is both SPDK and DPDK, they are basically do a lot of the stuff in user mode that traditionally the COM stack or storage stacks did in the kernel mode. As a result, so one of the things that Jim talked about is the threads. If you purely look at the CPU utilization, it looks like you're really doing well because your thread CPUs are really doing busy and doing a lot of work, but all they're doing is really because it's a user mode polling driver, they're constantly looking and seeing, is there something to process? Is there a new packet to process, or is there a new I/O operation to do? And so, so we added awareness basically so you could actually understand that, okay, what portion of that is really useful work and what portion is not, because we have instrumentation in SPDK, DPDK to give us that information. So, and then maybe that's a good place to stop. I have more files here than I probably need to go through. So, but they are there and we'll be posting them so you can look at them. But if there is interest, I can spend a few more minutes, but if not, then I might skip these things. Let me just flip through them and show you. I think the key point here is essentially the advisor, you can actually try to size up whether you could parallelize certain particular code region, right? And to do that, you're going to go through, you don't have to really make all the code changes. Using advisor, you can actually model it. Right? The key point is you can prototype, we call it fast prototyping. Really what it is you add annotations to the code, and then it can actually start to then do further analysis to see if it is going to be profitable. So it will give you a list of things to extract, parallelize, and then you can say, okay, I want to do this. It will tell you, okay, you need to add synchronization here, and then it's also going to give you in terms of how much speed you might get if you do that, because in parallel programming, you're not just going to get linear scaling if you have a lot of synchronization to do. So it can model that, or it can also tell you to, again, same modeling, how much synchronization you needed to add, right? That's the same thing. Inspector does it on the real parallel program, whereas advisor does this through projection, what we call projection. That's probably the key thing to learn is you can do some of this modeling. Same thing with offload in the future. You don't have to really implement an offload, a particular kernel or a loop before you figure out it is going to give you any benefit. It's actually going to tell you, hey, it might get some benefit if you do it. And then also give you some estimate. That estimate is not going to be 90% or 100% accurate, but it probably is close to 90% accurate, right? It's not higher than that. And that's good enough during the prototyping stage. That's the key thing. And let me just stop there. Yeah, that's. Yuri, one quick question. Looks like this is 45 minutes, not 30 minutes. Then.
Yeah, it's 45 minutes.
5 more minutes. So we have time for questions. Maybe.
大家有问题吗？
kernel mode profiling，当然是的，可以的。
Vtune, absolutely. Right. And then advisor, inspector or not. Right. So advisor, inspector are mainly for your application analysis. Right. So, but Vtune can do system level profiling, and even when you do application level profiling, it can go all the way to the kernel level. So you can see the full stack. So basically the way to think about Vtune is not only kernel mode, you can go all the way to the hardware. So you're getting the actual performance metrics in terms of how the hardware is behaving. Then you're getting some, you can actually unwind and figure out what's happening in the drivers or any kind of kernel modules. And then you can actually look at it in the user mode code. So you can see entire thing in the same integrated profile. Yeah. Any other questions?
Since the tool is very powerful to profiling memory, CPU, and I/O, so his question is it, from the profiling is all collected all together, or it can be customized to collect just one CPU, or just on CPU side, or memory side, or other side?
Good question. So the way Vtune analysis are organized is we get a lot of the data you talked about, but we also have different analysis types. So sometimes we get more data based on the analysis type in different aspects. So we may not collect everything when we're doing microarchitecture analysis. We get a lot of the same thing. But when we're doing the memory or I/O analysis, those are different analysis types. We are getting a lot of additional from the software, so hardware layers, right? So the memory controllers and the I/O the PCI Express complex. So so what was the second question? So can it be customized? So in general, you can typically you can take an analysis type and you can customize what metrics you want. It wouldn't be so if you're an advanced user, you can take an existing analysis type and then you can start to customize. So certain things like I want to add this particular event type or that event type or not. So, but there are certain core events we have to collect for that particular analysis set, and those are not something big. So yeah, customization is possible, but it is also, if you're going at that level, then essentially we tell which CPU, so you can use masks, I think, right? So CPU masks, and so I want only data from this particular one. And in addition to that, you also have what are called pause resume. So through API or through the UI in the GUI in the Vtune, you can say, I want to now pause data collection, and then I want to resume. So that's basically during the execution of your application, when you're profiling, you can figure out when you want to basically collect the data. And you can do that programmatically as well. You can add an API into your application that says, I want to pause now data collection, and then I want to restart data collection.
So he's asking the overhead from the progenitor. So what kind of what impact for if they use it on the production environment? So
yeah. So the platform profiler is going to be minuscule. I think probably less than 1% or maybe small fraction of 1%. Not a lot of overhead, and even some of the analysis in Vtune, especially the advanced hotspots or microarchitecture analysis, they also are not very expensive because the way we collect the data is basically the hardware has monitoring capabilities, and then we use those monitoring capabilities, and so the overhead tends to be 1% or around that. It also probably varies a little bit because there are ways you can figure out at what frequency you want to sample the data collection, right? Because these are essentially, this is a statistical data collection, right? So you're essentially every 10 milliseconds or 100 milliseconds, you can collect data. But if you dial it too big, right, the interval is very large, you might not have a very detailed profile. But if it is still meaningful for your particular application, then that's fine. But typically out of the box, we try to set the intervals to be, sampling interval to be around 10 milliseconds. So that means we are essentially taking maybe an interrupt, a PMI every 10 milliseconds.
那个是 overhead 本身是很小的，而且你是可以控制的。好，有人有问题吗？
我想问一下，就是我们识别它的 bottleneck 的时候，一般会认为就是我把某一项资源用光了，是因为它是 bottleneck。但是特别是在云环境下，我们会主动的去限制一些这个任务的资源使用量，比如说我们会限制60%的 CPU 和50%的 I/O 吞吐。但是从结果分析上来看，比方说我跑到了60% CPU 和5%吞吐。通常会认为它没有 bottleneck， 但是其实 bottleneck 的 CPU 上，这个就是它能够去识别我们在主动限制资源占用量的情况下，它的 bottleneck 在哪儿呢？
That's one question. So the question is, I can answer actually.
You can answer.
Yeah.
You can go ahead and answer.
Yeah. 是这样的，就是说你在收集 CPU 资源的时候，比如说你设置了50%的那个 CPU 隐含性，但是我们 Vtune 在采集的时候呢，那采集的时候它那个是按照 CPU 的实际的使用时候那个去采集的，就是说你即使设置了50%的使用率， 那我 CPU 在Vtune 在采集这个数据的时候，还是依据你的50%的这个使用场景去采的。这个时候你还是可以看到，在这50%的场景下面，它的 bottleneck 是什么，然后这里面碰到的问题是什么，就是。对对对对。是，对，它总归是按照你现在 CPU active 的那个状态去采的，非 active 的状态的话，你是那个本身我是采不到的。你这个时候你就看到的，比如说在 Vtune 里面的话，你采到的数据，你按照热点去采，所以你的最高的使用率就是50%。如果你超过50%，就说明超过你的限制了。如果低于50%，这个时候你依然可以看到，在低于50%的场景下面，哪些是热点，哪些是这个 bottleneck。不需要配置，默认就是这样子。它的采集的方法的话，跟你的限制是没有什么太大关系的。它采到的数据的话，比如说从热点上来看的话，你在时间线上面看到那个热点，其实就是它的使用的那个utilization。你认为你希望它是50%是最高，那你看到的它展现给你的数据就是50%。不需要，它给了你的数据就是已经到50%了。如果超过50%，你就认为超过你的限度了。是。但是我们 Vtune 里面的话，它会给的你是一个报告嘛？这个报告的话，对你去看这个数据就行了。Persistent memory， so lastly how Vtune supports the persistent memory.
Sure. So in fact, Jackson is going to talk extensively on that. So you can raise your hand. So please attend his talk. But basically, quickly, what it does is, so we essentially the persistent memory. First of all, persistent memory is a technology. So, but we can use it in two different modes, right? So we can use it in the memory mode, which essentially is using a different protocol from a memory controller perspective. It's using DDR-T protocol as opposed to going to the DRAM. It's using it at the lowest level. But from our point of view, we collect those events from the memory controller. So you get the same level of coverage, whether it be DRAM or is going to the Optane DC persistent memory module, the traffic, right? The reads, writes. And then you get into the more of the, so when you are in the memory mode, you are also doing DRAM caching, right? Basically memory mode is basically, you can think of it as a two-level memory, where your persistent memory module is your second level, and then the first level is basically your DRAM, which is acting as a cache. So in that case, you can break it out too. In Vtune, we know whether that particular traffic is really because of cache-related thing, right? So in the memory mode. So and if it is in the app direct mode, then you still can see it based on, because essentially you can see the memory transactions that we sample and we collect. We can break it out and tell you which ones are going into an Optane DC DIMM and which ones are going into a DRAM, and you can even break it down by each DIMM. But I hope that answers your question. But if not, here is the expert.
除了今天上午这个 topic 的话，我们还有另外好几个 topic 是关于 Vtune 的。那 persistent memory 啊，还有包括 SPTK 的，特别是我们的 Jackson 今天下午会有讲。然后明天的话 ，Shuta 就是我们坐在后面的一位女同事，也会有很详细的关于 PMDK 的一些 performance monitoring 的一些介绍。那今天上午的话，我们就先到这里。然后下午的第一讲也是在这个会议室。那到时候的话，我会用中文跟大家分享一下这个怎么去用 Vtune， 然后怎么去做一些实际的案例的一些分享啊，怎么去用这个 Vtune 去做这个性能分析。那希望大家能到时候准时参与。那今天上午就先到这里。谢谢大家，谢谢。
Thank you. So I want to do one shout out for Ang. Ang is actually in Shanghai, and he is our lead consulting team lead. So if you guys want to follow up and actually get more in-depth training and things like that, reach him, right? So we're happy to help you, and then he'll pull us in as needed. So we are in US, but we always are in contact.
这是王婷。好，谢谢大家。